March. So the semester will be happening in March. So you can think of that January and February will be too much busy schedule. Okay. So you'll have to give at least 3 continuous assessment at that time, and then 2 continuous assessment for practical also. So after that there will be exam. So don't know whether exam will be uh, taken coming over here, or whether it will be again that online mode. बट समझ में आ रहा है, सब लोग बोर हो रहा है घर में बैठ के, बट कुछ कर नहीं सकते. हम लोगों को भी बहुत ख़राब लग रहा है, और हम लोग भी परेशान हो गए अभी ऑनलाइन क्लास लेते लेते. बिकॉज व्हाट इज़ हैपनिंग इन ऑनलाइन क्लास, वी आर नॉट एबल टू इंटरेक्ट with each other properly. That is what is my feeling. Means one to one जो interaction होता है, आई कॉन्टैक्ट्स होता है, एंड देन कुछ अंडरस्टैंडिंग प्रॉब्लम है तो डायरेक्टली डिस्कशन हो जाता है क्लास में, वो नहीं हो रहा है. सेकेंडली, many of you are not listening. That is what is my perception, and I have verified it also, that many of you do not listen to the class. I am not saying this today's 10 student whosoever whoever is attending this class, but many of the cases I have verified that लोग बाज़ार में है, ठीक है, बाज़ार कर रहा है और फ़ोन स्विच ऑन है. एक दिन तो मैं सिविल 1 का कोई लड़का को देखा कि वो मछली पकड़ रहा है उससे. सो बैठ के मछली पकड़ रहा है, वीडियो ऑन करने बोला तो वीडियो में देखा कि मछली पकड़ रहा है बैठ के. तो ये सब चल रहा है, बट क्या कर सकते हैं, ऐसे ही चलेगा. यू कैनॉट हेल्प इट. But what is my advice to you, that if you neglect these classes, okay, then it will be only the problem of yours, as well as it will be problem for us also, because you see, based on these discussions only, question papers will be set up. Forget about examination of university. Based on these knowledge only, in the next semester whatever you will be studying, that will be based on. So अगर इस सेमिस्टर में फाउंडेशन ठीक से नहीं सीखा, सो अगले सेमिस्टर में अगर एडवांस फाउंडेशन का कोई कोर्स लेना है, सो हाउ डू यू अंडरस्टैंड इट? यू विल नॉट बी एबल टू अंडरस्टैंड. सो दैट इज़ व्हाई आई टेल यू दैट you should at least go through whatever is being taught in the class. Okay, so let's start the discussion and see what is. So let's see that today we'll try to take up a problem. Okay, so we'll take up a problem from force method of analysis. Okay, and the problem basically will take for a propped cantilever beam. Okay, so in this kind of beam, a propped cantilever beam having UDL on it. Okay, so you see, if you want to analyze a propped cantilever beam using with UDL, then what will be the method of analysis, that we will discuss. But before that, if you remember, in the compatibility method of analysis, as you have understood, that we have seen that displacement finding is very important, because under any force what will be the displacement, under unit force what is the displacement, and if any force is acting, any amount of force is acting at that point, whatever is the displacement, that you have to study. So you need to remember the displacements for typical kind of beams subjected to different kinds of loads. Okay, so you should remember. So if you see this force method of analysis, this force method 1.pdf, that is the first one. Please refer to this. Okay, so please see this 459 page, whatever you see here, that is not very clearly visible, that is not very well scanned. I have given it in the next PDF, that is force method 2 PDF. This is the same one. Okay, so where from you should start this reading this PDF? Actually, you should first concentrate on this part. You should first concentrate on common beam displacements. You must remember these common beam displacements. So I have given you a chart from a book written by Roy and Chakrabarti. So it's a very comprehensive kind of things which is given in a tabular format. Okay, so you first try to see what is being said over here. So if you have a beam something like this, so what kind of beam this one is? This one, it is a simple supported beam. Okay, so in a simple supported beam, at a particular end, if you provide a moment, m, then what will be the rotation, what will be the angular rotation at support A and support B? That you should remember, because many cases you will be requiring it. Okay, so suppose you want to analyze a fixed beam, in that case you may be requiring these kind of values. Okay, as well you will have to remember what will be the displacement at particular point of that beam because of this moment being applied over here or external forces being applied over here. Okay, so you see this moment m, if you apply at point B, you are getting theta A is equal to minus ml by 6 ei, theta B is equal to ml by 3 ei. Okay, so you should understand it. It is vice versa. That means suppose this moment you apply at A, suppose instead of B you apply it at A, then what will happen? In that case it will be just reverse. That means theta A will be in that case ml by 3 ei and theta B will be ml by 6 ei. Now the sign convention of theta A and theta B, it will all depend on you, how you are treating the rotation. If you think that clockwise rotation you will take as positive, you put a positive sign. If you think that you want to take anti-clockwise rotation as positive, you put a positive sign. It's all up to you, but you will have to follow a total completely similar convention throughout the problem. So either you can take clockwise rotation as positive or anti-clockwise rotation as positive. Either you can take clockwise moment as positive, anti-clockwise moment as positive. It's all up to you. And also you will have to find out, you will have to see what is the displacement at particular or specific point. So see, when a moment is being applied over here, you see at the middle of the beam, in a simple supported beam, the moment will be something like this. So L by 2, this delta L by 2, when you see, that means it is at the middle of the beam. That is ml square by 16 ei. So all of you must remember this. All of you must remember this. Okay, because if you can remember these values, you will see these values can be obtained using the methods you have already learned. That is your conjugate beam method, your moment area theorem, and other things. Okay, the displacement at different points. Okay, however, while solving the problems using force method of analysis or compatibility method of analysis, you may not be having time or patience to again analyze and go back to the moment area theorem or conjugate beam method or any other method to find out the displacement at that point. So in that case, or even in case of your competitive examinations, you must remember these values. Then only you will be able to quickly solve the problems using force method or compatibility method of analysis. Okay, so now the different kinds of things are given. Now you see just what is the difference between this beam and this beam. You see, this is a typically simple supported beam, whereas you see this is a propped kind of cantilever beam where at the propped end you apply a moment m. Now you see in this case there will not be any rotation at A, because end A is basically a fixed end. So when the end A is fixed end, there will not be any rotation. So obviously the theta A value will be becoming equal to 0. And you see because of this m being applied at B, the rotation at B, that is theta B, will be ml by 4 ei. Okay, and the displacement at this position will be delta L by 2, that is ml square by 32 ei. If you observe, this is exactly the half of it. It is exactly the half of it. Okay, so ml square by 16 ei, it is the half of it is ml square by 32 EI. Now these are very critical and typical cases. You must remember these values. Many cases you need this to be applied while solving the compatibility equations, okay, or finding out the compatibility equation. Now you see, let us come to a very simple kind of structure. So what is this? This is basically a cantilever beam. So you must remember, if in a cantilever beam a P load is applied at the end, you see the displacement at the bottom, displacement at middle of the beam is PL cube by 48 EI. Displacement under the load, that is delta B, is PL cube by 3 EI, and the theta B, that is the rotation at B, so there is no rotation at A if you see. So theta A will be also in this case equal to 0. So theta B will be equal to PL square by 2 EI. Okay. So you see, if you want to solve a problem of prop cantilever, as I was discussing with you in the previous class, so if you want to solve such kind of problem, you see, you need to remember the cantilever displacements, okay, under different kinds of loads. And you see, when you take different kinds of loads, that means what I say, that suppose a cantilever is subjected to a point load along with a uniformly distributed load and a moment, then what you will have to do? You will have to just superimpose those. That means displacement due to a point load, displacement due to uniformly distributed load, displacement due to moment needs to be just added up to get the value of displacement at a particular point. Now when I talk about displacement, it may be either the vertical displacement, it may be either the or the horizontal displacement, or it may be rotational displacement also. Okay. So you see, a point load P, so it will be PL square by 2 EI, delta B will be PL cube by 3 EI, here it will be PL cube by 3 EI. You must remember this value, PL cube by 3 EI, very important, okay. And under a point load at a cantilever, at the middle of the cantilever, it will be PL cube by 48 EI, okay. Now similar case, when it is a cantilever and a moment will be applied at the end, then you see your theta B, that is the rotation at B, will be ml by EI, and your delta B will be ml squared upon 2 EI. Delta B means the displacement at B. When a moment is applied over here, then delta B at this point will be downward, and it will be ml squared by 2 EI. And just like the previous one, see, at the middle of the beam, that is at L by 2, it will be ml cube by 8 EI. Okay. Now if the cantilever beam is subjected to uniformly distributed load, see this one, this is the case of uniformly distributed load. So W per unit run, it is running. So you see, the value of the delta B will be W. So W is the load per unit run, L to the power 4 by 8 EI. See the difference. So when it is a point load, it is PL cube by 3 EI, whereas when it is uniformly distributed load, it is W L to the power 4 upon 8 EI. Okay, and at the middle, the deflection will be 7 WL to the power 4 by 192 EI, and the theta B, the rotation over here, will be WLQ by 6 EI. So see, all these values you should try to remember. See, in a single day you will not be able to remember it, okay. But if you try to remember, if you practice different kinds of problem, then automatically you will see, you will be able to remember the values, okay. And you will be able to correlate the values among itself, and you will be able to remember it very easily, okay. Sorry. Now you see, this is a simple supported beam. Now you see, what is the difference between the first one and the second one? See, in this case it is a simple supported beam, but it was being acted at one support by an external moment. So that is different than this one. You see, in this case it is a simple supported beam, and it is being acted upon by uniformly distributed load W per unit run, and because of that you will be able to find out theta A and theta B. So theta A will be exactly equal to theta B equal to WL cube by 224 EI. Very important, you must remember this. And at the middle of the beam, the displacement will be maximum, and at the middle of the beam, displacement will be 5 L to the power 4 by 384 EI. You must remember this. So and at the L by 4 distance, the displacement will be 9 WL to the power 4 by 2048 EI. Okay. Now you see, this is a typical beam where a point load, this is a simple supported beam where a point load is acting at the middle of the beam. So because of the point load being acting at the middle of the beam, you must remember this value also, and the delta at L by 2, that means at the middle of the beam will be PL cube upon 48 EI. Okay. See, because of the UDL, it is 5 WL to the power 4 by 384 EI. Because of the point load, it is PL cube by 48 EI. You must remember these values. If you do not remember these values, I tell you that you will not be able to solve the compatibility method problems, because compatibility equations will be generated using these values of displacement. So displacement means either vertical displacement, horizontal displacement, or rotational displacements. Okay. So going forward, you see, when a P is being acted at a distance L by 4 from the beam, so for that also you should try to remember. So considering all these things, it's a good chart. If you see, it covers almost many cases being covered over here. So you see what is being covered in this under this chart. You see a cantilever beam is being covered. So 1 case, 2 case, 3 case. So cantilever beam under a point load at the end, cantilever beam under a moment at its free end, cantilever beam subjected to UDL, then a simple supported beam under UDL, simple supported beam under a point load at the middle point, simple supported beam under a point load at a distance L by 4 for mid, or you can say at any distance from any support. Along with that, if you observe the other two cases, this one is a simple supported beam where a moment is being applied at the roller end, and this one is a kind of a propped cantilever where a moment is being applied at the propped end. So if you remember all these values, if you can remember all these values, you will be able to see that very easily you are forming the compatibility equation. Okay. So considering taking this guidance of these formula, let us now try to see the step-by-step method of force method of analysis. Okay, step-by-step method of force method of analysis. So if you see the step-by-step method, it is given something like this, and you can very easily see that first thing for analyzing any indeterminate structure using compatibility or force method, first thing what you will have to do, first thing you will have to determine the degree of indeterminacy of the structure. So this is the step 1. So at the first step you will have to determine the degree of indeterminacy of the structure. After that, what you will have to do? So depending on the number of indeterminacy, so number of indeterminacy, either it can be external indeterminacy or it can be internal indeterminacy. So external indeterminacy means the reactions at the support. So when we talk about reaction means either it may be vertical reaction, it may be horizontal reaction, or it may be moment also. Okay. So reactions, external reaction, and the internal member forces. So you find out first the indeterminacy, then you try to find out whether it is internally indeterminate or externally indeterminate. So depending on its indeterminacy, first you choose the redundants. And what are the redundants? Redundants are nothing but the reactions, okay, which are unknown. That's what we have discussed, right? So redundants means the unknown forces which you need which you cannot find out using the equation of statics. Redundants are those forces which you need to find out using the equations of compatibility. So you first choose the redundant reaction. So once you find out the redundant reaction, what will happen? So what is exactly a redundant? So a redundant, when it is being removed from the structure, then what will happen? The structure will necessarily become a determinate structure. So redundant should be such, and you will have to choose your redundants in such a way that after removing the redundants, your structure should be remaining as a stable structure, and the structure will become a determinate structure, and such structure you will be calling as primary structure. Okay. So once you know your primary structure, what you do? You subject your primary structure to different loads. Okay. So what load? The external load. So considering the external load, you find out the displacement at the point of the redundant. So whichever point you have removed the redundants, okay. So wherever points you have removed the redundants, at that point you try to find out the displacement. Because of what? Because of the external load which the structure is being subjected to. Okay. Now once you have done it with the external load, then you forget about the external load. Next you do what? You take the you take the primary structure again, and in that primary structure only apply the redundant forces, and applying the redundant forces at the same point you try to find out the displacements. So the displacement at the point of the redundant forces should be equal to each other, because either they will not be moving or they will be rotating, or rotation will be equal to 0, something like that. That compatibility condition you will have to apply, and from that you should be able to formulate the compatibility equation. Okay. So once you have found out the compatibility equation, you should be able to find out the redundant forces from that. But you should remember that if you have one redundant in a structure, from one equation you should be able to find out it very easily. But if you have multiple redundants in a structure, in that case, for each and every redundant you will have to get or formulate one compatibility equation. Okay. So that compatibility equation, from that compatibility equation, what you will be getting? You will be actually getting multiple number of simultaneous equations, and you will have to solve those simultaneous equations. So those simultaneous equations, one part will be called as flexibility coefficients. So what is flexibility coefficient? So if you remember solving simultaneous equation, you can easily solve using matrix method of analysis, or you can apply any method of analysis of solving simultaneous equation. So when it is 1 or 2 degree redundant or 3 degree redundant, then you can very easily use any method of finding it out. But if it is more than 3 degree redundant, more than 3 degree indeterminate, so you may be getting, you will be getting, your number of redundant forces will be more, and your simultaneous equations will be also more. So in such cases, what you will have to do? You will have to formulate matrix kind of equation, and then using matrix inversion technique you should solve the values of the redundant reactions. So once you have got the redundant reaction, once you have got the redundant reactions, so what you will have to do? Once you have got the, so in case of several redundant reactions, as I have explained, solve the compatibility equation simultaneously, and for solving this simultaneous equation you can use matrix equation and matrix method of analysis. Okay. So once you have found out the redundant forces or moments, what you will do? Apply the computed redundant forces or moments to the primary structure, because now you see in the primary structure you have your original loads and you apply the redundant forces, because now you know the redundant force. Okay, so it is now known to you, and evaluate the other functions in this case means other reactions or other deflections such as bending moment, shearing force, deflection, whatever you want to find out. So once you have found out your redundant, that means essentially from the indeterminate structure, the structure has become a determinate structure, and once you have determinate structure in your hand, you can apply equations of statics or equilibrium equations of statics, that is sigma fx equal to 0, sigma fy equal to 0, sigma mz equal to 0, and you can very easily solve the other component of things from the structure for the structure. Okay. So understanding this method of analysis, after understanding this method of analysis, we will take up one problem. But before that, I ask you, is there any doubt up to this point? Tell me. Any doubt? No doubt?
No, sir.
Okay. So if you do not have doubt, then I just take one problem. See this one. So now you see this problem. What is this? So you see, typically if you see this problem, this is a propped cantilever, right? This is a propped cantilever. I have taken this up previously also in the first class where we have discussed about this propped cantilever analysis also, to how to find out primary structure and other things. Okay. So if you take up this problem, you see this is typically, if you take this problem. So what is this problem actually? If you take it up, so let's say this is your problem. Okay. So in this problem you see a UDL is being acted on a propped cantilever. Okay. So once a UDL is acted on the propped cantilever of length L, then what you will have to do? So if a UDL is acting on a propped cantilever, what will be your redundant? So first thing, before finding out redundant, you must understand what will be what is the first step? You must find out what will be the degree of indeterminacy, right? What will be the degree of indeterminacy? So you tell me now, what will be the degree of indeterminacy for this propped cantilever? Tell me. So if I take a propped cantilever, what will be the degree of indeterminacy? Bolo? So what is a propped cantilever?
Indeterminacy 1, sir.
1, sir.
Indeterminacy will be 1.
1.
Where it will be? So see, how you will be identifying it? See, there are two supports. One support is A, one support is B. So at the support A, at A it is what? It is fixed support, right? So at the fixed support, you have how many reactions? So if you neglect the horizontal component of reactions, you have two reactions, right? So what are those two reactions? One is vertical force. One is vertical force at A, and other one is Other one is
Moment.
what? Bolo?
Moment,
Moment.
sir.
Moment. Moment at A. So there are two reactions at A. I am not considering the third one. Which one is third one? Third one is the horizontal reaction at A. Why I am not considering it? Because this system is only subjected to a vertical force, that is W per unit run. And what are the next thing? At B. At B, what is the support? It is the prop end, right? At this point it is a prop end. So at B it is propped end. So when it is a propped end, at the propped end, which kind of support is there? Either it is a roller support or it may be a pin support. Both it can be, okay. So either it may be a roller support or it may be a pin support. So considering that there is no horizontal reaction is happening, so think about that there is no horizontal reaction because the system is acted upon only by vertical force. So which force will be coming in this case? The vertical force at B, correct? So how many unknowns now you have? So unknowns you have now how many? So unknowns will be equal to two reactions here, and one reaction here, right? So 2 plus 1 is equal to 3. Now how many equation of equilibrium you have? Equation of equilibrium, don't confuse here, okay? So see, equation of equilibrium in this case we are having 2. Why? Because we have not considered what? Horizontal component of force, okay. So the available equation from statics, so available equations from statics will be 2. What are they? Sigma mz equal to 0 and tell me,
Fy.
summation of all the forces in y direction equal to 0, that is sigma Fy equal to 0. So what will be degree of indeterminacy? So in this case doi I will determine, so doi will be 3 minus 2 is equal to 1. So okay, fine, doi is 1. So first step we have done. So for analyzing a particular indeterminate structure using force method of analysis, first thing you will have to do what? You will have to find out degree of indeterminacy. So you have done it. Now next step is what? Now you find out what is the redundant, right? So out of these forces, or out of these degree of indeterminacy, so one is over here, so there is one redundant, right? Now you will have to choose the redundant properly, okay. So once you choose your redundant properly, so what is redundant? Redundant means if you remove that force, that is the unknown force, whatever you have in the structure, if you remove it, then what should be there? The structure should remain stable. So what can we do? If we remove this, that means if we remove the reaction at B from this structure, then what will happen? This structure, this prop cantilever will necessarily become a cantilever beam, right? And in that case it will become a cantilever beam. So actually you see, is this one is one indeterminate beam. So I'm again writing it from here. So you see, this is actually a indeterminate beam because this RB is over here. Now if I just remove this redundant, so which one is redundant in this case? If I remove this RB, that is the redundant, if I remove, then what I will get? I will get a primary structure, something like this. I will come to the displacement later on, okay. So what I will get? So if the redundant is removed, then what I will get? I will get a primary structure, something like this, okay. So this is not displacement. Please note it. This is not a reaction. This is basically displacement. Okay. So sorry, this is a cantilever beam. So actually, what we are getting a purely, or I think this figure will confuse you. Just a minute. Let me little bit. This one. Now it should be clear. So you see, so there is no reaction at this point. There is no reaction at this point. So what we have done, we have removed this redundant. And what is this redundant? This redundant in this case is RP. Now if I remove this, then you see this structure necessarily remains a stable structure, and you see this is necessarily a cantilever beam, and this structure we will call as primary structure. So we have removed the redundant, we have seen what is the primary structure. Now after this, what is the third step? So second step is also done. Now after you have done with your primary structure, what you will have to do? What is the step I have told? So at the point of the redundant, so what is the point of redundant over here? So redundant point is over here. So at the point of the redundant, you find out displacement in the primary structure. So displacement in the primary structure at where? At B. And what is B? What is B? B is the position of the redundant. If you see, position of the redundant. So at the position of the redundant, you now have to find out what is the displacement. Now you tell me what will be the displacement at this point. Can anyone tell? Bolo.
WL cube by 3EI.
WL cube by 3EI. WL cube by 3EI. Okay. Let's see. So see, that is where you will be requiring this. You see, this diagram. You see, now what you are having? You are having a cantilever beam subjected to uniformly distributed load, and at the point B, you will have to find out the displacement. So you see, the value you have said it is not correct. WL cube by 3EI. It is the case when a cantilever beam is subjected to a point load at the end. When it is subjected to UDL, it is not WL cube by 3i, it is WL to the power 4 upon 8i. Okay, WL to the power 4 upon 8i. Okay, so what will be the displacement? So let us write over here. So delta, I am writing it like this. So delta at delta B. So delta B will be equal to how much? So what should I write? W
WL to the power 4 8EI.
WL to the, this value, you see this value, WL to the power 4 by 8EI. Now you understand how these diagrams are important, how this chart is important. So all these values you should remember. I will take up one by one problem and you will understand why you should remember all these values. Okay, so you see, now for a simple problem, first problem, you see, you need to remember this, and you will get the value W L to the power 4 upon what? 8 EI. What is E and what is I? E is the modulus of rigidity and I is the moment of inertia of the beam. Okay, so EI is basically, what is this term called? EI is called flexural rigidity, right? So you have seen what is the delta B. Now what is this delta B? Delta B is nothing but the displacement at B due to what? Due to this load, external load acting on the structure. Now you see, in the next case what will happen? You see, in the next case, when you take this structure, when you take this load out, as I was telling you, if you take the load out from the structure, and if you just consider only the structure subjected to a point load over here, that means what is the point load in this case? So suppose I take the structure, rather I'll just take a paint and do it, otherwise it will be little confusing. So let me remove this first. So just take it and just remove it. So just remove this, okay. So, and also remove this. So what you have, so you see, if I remove everything, so what you are getting actually, you are getting, you see, you are basically getting a cantilever beam. So a cantilever beam, forget about all these loads and all, okay. Now in this beam, you see, what will be the next step? In this beam, you should be applying your redundant force. So what is your redundant force over here? This is your redundant force, okay. So at the end, if you apply your redundant force, so redundant force, let me change the color. So if you apply the redundant force, so what is this redundant force? This redundant force is nothing but the reaction at B at the prop end, right? So because of this redundant, so suppose this redundant is having basically value of what? RB. So RB is what? RB, you see, RB is nothing but a point load. It's a point load. You see, a point load is being acted on a cantilever from the below end. So what it will do? It will just displace the structure in the upward direction, okay. So you will find a deflection of the structure similar to this kind. So you see, you will be finding out a displacement of the structure similar to this. So I'll just draw it again here. You see, so you see, now you see, because of this RB, so this is your RB, right? This is your RB. So this RB now, when is being applied over here, it will deflect the structure upward. And what will be the displacement? Now again you will have to go back to here. So now someone has told that PL cube by 3I. Now you see that delta B, because of this P, is PL cube by 3I. So because of this RB, now we will be getting a displacement over here, that is RB into L cube by 3R. In this case, this P is being replaced with RB, isn't it? So now you see, from these two conditions, from these two things, so once you have got W delta B, so at this point you see, when this at this prop end, ideally there will not be any displacement. Ideally should not be any displacement. That means the downward displacement should be equal to the upward displacement. So what I can write? I can write W, or let me take it from the top. So I can write it control. So what I can write? I can write this one, right? This is downward. If I take this displacement as positive, then this displacement, this one which is upward, I can take it as negative. So this minus RB into LQ, RB into LQ divided by 3 EI. This should be equal to how much? Tell me. How much the value should be equal to? Bolo?
0, sir.
0. Yes, absolutely. It will be 0 because at the point of the prop end, the upward deflection because of the redundant on the primary structure and the downward deflection because of the external load on the primary structure should be same. Otherwise, the structure will not remain stable at all. Okay. So, considering this, you can easily find out the value of RB. Okay. So, see, which is your unknown in the problem? Your unknown in this problem is nothing but your RB. So, you can easily find out the value of RB from this. So, what? Sorry. How much will be your value of RB? If you solve it, you are going to get it 3 upon 8 W into L, because W L to the power 4 and L cube, this L cube and L4 will cancel out. So, you will get 1 WL on this, and then you will be having 3 by 8. So, I should write it somewhere like this, otherwise it will be confusing. 3 W into L divided by 8. Okay. So, what you have done through this? So, you see your unknown in this structure, only unknown or the redundant force was this RB. Now, this RB, value of this RB you have found out. So, once you have found out the value of RB, you can very easily apply the equation of statics and you can find out all other forces in the structure. Is it clear? Is this clear? So, now,
Yes, sir.
so once you find out this RB, you see what you can do. You can take the cantilever beam. Okay, you can find out because of UDL what is the bending moment. Okay, so you see, because in the cantilever beam, when a W moment is acting on the beam, so what is the moment? It is WL squared by 2, isn't it? At the fixed end, what is the moment? WL squared by 2, right? Now, because of this 3WL upon 8, what will be the moment? Because of this 3WL upon 8, there will be moment 3 WL upon 8, and what will come? Multiplied by L, because at the fixed support, this load, this RB is acting where? RB is acting at this point, right? So, if I take, now you see I go up. So, you see this is your RB. Now, you know your RB. So, because of this RB, how much moment will come at A? Because of RB, this RB into L. Now, RB is known. So, what is RB? RB is nothing but 3WL by 8. So, 3WL by 8 into L, which will give you 3WL squared 3WL squared divided by 8. Now, you see one moment, because of this uniformly distributed load, when you just consider this cantilever beam, this will try to rotate this point in this direction, whereas when you consider this, it will try to rotate this in the reverse direction. So, obviously, the sense of these two, that means WL square by 2, which is because of the UDL, and 3WL square by 8 will be different, right? So, what you can do at A, if you want to find out the moment at A, so at A, how much will be the moment? You can easily do this WL square upon 2, WL square upon 2 minus of 3WL squared upon 8. So, if you solve it, how much you will get? bolo. Sorry, how much you will get? Tell me. Three WL square upon 8.
WL square upon 8, sir.
WL square upon 8.
8.
Right? WL square upon 8. Will you get it or not? WL square upon 8. Okay. So WL squared, sorry, WL squared upon 8. So this is actually your moment at A. Now you see. So because of the cantilever, because only it is being cantilever, you had moment WL square by 2. Now you see, because giving a prop end, just adding a roller support at the end, you see what you have done. You have reduced the moment to WL square by 8. To WL square by 8. So that means how much you have reduced? Almost 1/4, right? 1/4 moment have been reduced at this support. So what you can do, your this support, whatever you are preparing over here or constructing over here, that may be little bit and 1/4 less stronger than whatever you have only for the cantilever, and that is what is the benefit of indeterminacy. Now you can see. Okay. So in the next class we will take up more problems. I have sent you the problems also. Okay. So we will be taking a fixed beam in the next class with a point load, okay, and we will try to understand that. But before that, I tell you, you please go through the problems whatever I have sent. That two PDFs I have sent you. Okay. So one is your this one is this force method 1 and this force method 2. So in force method 1 you will find there is another one problem given, that is for fixed beam. I will be taking up that problem in the next class. We will discuss it, but you should go through that. But in force method 2 there are other typical 2-3 types of problem given. I will not be getting into each and every problem in detail, but I will be giving you the hint of those problems. Okay, but you must go through those problems, you should at least try to solve those problems your own. So I will give you one homework, that from the force method of analysis, this force method 2, the first problem whatever is given, that is example 10.1 is given in that. So 10.1, the first problem you just try. That means what I am saying, in this you just try this problem. Okay, you just try this one. I have sent this. So you just try this problem. See, this is a typical prop cantilever, and in this prop cantilever what is happening? A point load is acting at the middle of the cantilever beam. So you just try to solve this problem. Okay, so we will see that whether you are understanding or not. Okay, so because of this you try to find out what will be the reaction at B, what will be the moment at A, what will be the reaction at A. So once you find out moment at A, reaction at B, the finding out of bending moment and shear force diagrams are very simple. Okay, so I advise you just go through these things and solve the problems your own. Otherwise you will not be able to solve the problems in the exam also. Okay, and also try to remember the values whatever I have sent out. Okay, so I think let us, already we have exceeded the time, sorry, exceeded the time today. So Google attendance collector क्या हो गया, अटेंडेंस नहीं होगा आज? Okay, attendance is taken, so you may leave now.